Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, is that a weed-killing robot? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week we're returning to the topic of agriculture and food, and finding out how robotics can help improve efficiency and sustainability throughout our food systems. This episode marks a very exciting milestone, my 100th interview for Robot Talk. It's been an incredible 4 years, and I've thoroughly enjoyed chatting to 100 different robotics experts and enthusiasts from every field of research, industry, and beyond. Check out our back catalogue of episodes for some great robotics conversations you might have missed. Before we get started, I'd like to remind you to subscribe to Robot Talk through your favourite podcast provider. It really helps the podcast and means you'll be the first to hear the latest episodes. Another way to find out about new episodes is our email newsletter, which you can sign up to on our website by going to robottalk.org. So, without further ado, let's get on with this week's interview. I recently had a really interesting conversation with Elizabeth Sklar from the University of Lincoln, all about agricultural robotics, human-robot teams, and sustainability. Today, I'm talking to Elizabeth Sklar, a professor in Agri-Robotics at the University of Lincoln, working on multi-robot and human-robot systems. Hi Elizabeth, welcome to Robot Talk.
Hi Claire, thank you for having me.
So you're research director at the Lincoln Institute for Agri-food Technology, which aims to improve productivity, efficiency, and sustainability in food and agriculture. So can you tell me a bit about some of the robotics research that's going on there?
Sure, I'd be happy to. The agri-food industry is something that's crucial, obviously, for providing the food that we eat.
Yeah.
And there's been many reasons in recent years why this industry is really in need of technology-based solutions to help the industry become more efficient, more sustainable, and more productive.
Mm-hmm.
As the population grows, we need more food to feed people nationally and globally. But the amount of land available for agriculture typically does not increase. And so we need to look at what are ways that technology can help. And so we look at a range of different things. Lincoln Institute for Agri-food Technology, also called LIAT, is an academic research unit within the University of Lincoln and the College of Health and Science. And so we focus on research that looks at three key themes in robotics. The first is called robotic phenotyping. The second is called crop care. And the third is called selective harvesting. I'll give you a quick overview of what each of those things is. Mm-hmm. So robotic phenotyping is the use of intelligent technologies to help identify traits that are visible in different kinds of plants. So this could simply mean being able to identify one type of plant versus another type of plant, like a crop versus a weed in the field. But it can also, for plant scientists, also focuses on looking at particular traits that show up in different varieties of the same plant. And plant scientists and plant breeders in particular look at different ways to improve the sort of yield volume of plants within the same geographic footprint of like a plot where plants are growing. So those are the types of traits that they look at. And largely, robotic phenotyping involves using computer vision. There are some work using other kinds of sensors besides cameras, but it's largely around cameras. Crop care is looking at what are things that need to be done in the field to tend crops. So weeding is the classic example, but also irrigation, different kinds of things that help plants stay healthy and produce the fruits and vegetables that are needed within the normal growing time frame. And robotic technologies can help with identifying when a particular type of resource like water is needed, can help deliver those types of resources. One of the things we look at a lot is robotic weeding, which could be a mechanical weeding device that's on a roboticized vehicle that's in a field, or it could be robotic spraying, which decides when should a particular herbicide or pesticide or fungicide be sprayed on plants in the field, again, using devices that are mounted on vehicles in the field. And the vehicles could be bespoke robots, but they could also be farm vehicles like tractors that have devices mounted on them to do the intelligent spraying or whatever. And the third theme is selective harvesting, which is looking at particularly for what are called high value fruits and vegetables. So things that are harvested one at a time, strawberries, raspberries, broccoli, cauliflower, different kinds of crops that traditionally a person in the field is actually cutting each one. You want to make sure that you're selecting only the ripe things to be picked so that you're maximizing the yield for the farmer and the marketability of what goes to the grocery store and what you see, as a consumer. So those are the key things that we look at. The aims with LIAT in terms of productivity, efficiency, and sustainability, the kinds of things that we look for with productivity. We use technology largely for what's called yield forecasting. So estimating, if you look at a field where things are growing, farmers and agronomists can estimate when is this going to be ready for harvesting, and how much harvest can we expect to get out of this field on this particular day or this particular time of day, because depending on whether it's raining or whether it's dark or light, and what the temperature is, some fruits and vegetables are impacted in terms of what time of day they're harvested.
Okay.
So these are all the kinds of things that get looked at. And that ties in with efficiency in terms of resource usage when we're looking at human resources. So one of the crucial issues that's hit the UK in recent years and many other countries, including the US, is around human labor for doing work in the field. And in-field farm jobs tend to be needing highly skilled laborers who understand the properties of a particular crop that says when it's ready to be harvested, and the physical skills to actually do the harvesting and carry the produce around the field. So people have to be fit and they have to be fast, and difficult to get people who want to do those jobs because the nature of the jobs are they're repetitive. And sometimes the work in the field can be uncomfortable. Maybe you're bending over, maybe the sun is strong, the weather's bad, whatever. They're just jobs that not necessarily desirable for everybody to do. And so we want to look at ways that we can use technology to help farmers make better use of the workforce that they have available. And so yield productivity ties in with that, because we can say, well, if we look at a particular field and estimate, well, how much produce is going to be available to harvest today, that will let us decide how many workers should we assign to that field today for that harvesting. And then you don't need to send, an overabundance of workers to do the harvesting if they're not needed. And, then that ends up wasting that human resource. So that ties in with the efficiency. The other aspect that we look at with efficiency, aside from use of human resources, is a use of natural and artificial resources. So in many countries, water is a scarce resource, or many regions in different countries. And I mean, even in the UK, although we have an abundance, it's a pretty wet country. Around the coastline, the water can have high salinity or high salt values. and all crops are not robust to growing well with high salinity. So, making sure that water usage is being expended efficiently is important. And then artificial, like chemical resources that are used for killing weeds. So herbicides, pesticides, which are used for killing unwanted insects, and fungicides, which are used for killing off different kinds of molds, fungi, for example. So you want to be able to use those efficiently because all of those things involve a cost. And farming is a very low margin industry. So the amount that a farmer makes on each crop is quite small. And so it's an interesting feature of the domain from the perspective of a roboticist, because every little cost is counted. And other application domains outside of agri-food don't necessarily look at costs in the same way. So there are a number of reasons, and that's one of them why I think agri-food is really interesting for a roboticist. And the last piece about LIAT is looking at sustainability. So obviously, we're in a period of climate change, ongoing, for many years, and becoming more acute. And so we want to make sure that the methods that we use are helping sustain the land, so that we're making sure that the energy that's required to implement a system is efficient. So you don't want to have a robot drive around a whole field if you don't need it to, if it only needs to be, a vehicle only needs to cover part of a field. So selectively deciding where you're going to send a vehicle to spray a pesticide, that feeds in with sustainability. Looking at the energy usage around some of these computer vision algorithms, like deep learning, can be very computationally expensive and very expensive from a energy usage standpoint. So what are ways that energy usage can be minimized, even though you're looking at methods that might require high performance compute cycles? And then, of course, looking at the use of chemicals. You want to minimize the use of chemicals because they can have damaging effects on the environment. And that also ties in with sustainability.
Yeah, the sustainability angle is something that really interests me. One aspect of that I don't think you've mentioned is kind of the soil itself. So I'm wondering, are there any robotic solutions that are looking at kind of monitoring soil conditions, which might then obviously impact yield, or like tell you that you need to apply fertilizer, or anything like that? Is there any kind of soil related robotic stuff that's going on?
So yes, there's a lot of work looking at soil, the composition of the soil, the resources like nitrogen, for example, that are in the soil. One of the reasons why historically farmers have done crop rotation is to make sure that the resources that are naturally available within the soil have time to rejuvenate before, say, the next crop uses them. And so farmers tend to pair crops in cycles of 2 or 3 over growing seasons to make sure that the soil has a chance to regenerate. And so, one crop might use a lot of nitrogen, then the next crop might use less nitrogen, so that there can be some regeneration. So that's one aspect. Another aspect is around carbon storage, and there's a debate in the farming community about whether to till the soil or not till the soil. And when you till the soil, you're releasing carbon. And so what are ways that if you don't till, can you keep that inside the soil for storage? And certain algorithms for performing robotic tasks within a field look at reducing what's called soil compaction. So when you have a heavy vehicle driving over soil, obviously you want to minimize the amount that the vehicle drives over the crop itself. If you do any rambling, you'll notice that there are tractor lines, across fields. And so every place where there's a tractor line, you're not going to grow something, or it's going to be a very small yield. And so how do you keep the tractor lines clean and reduced so that you're not diminishing the amount of yield that you could have in that field. Mm-hmm. So those are some of the things that are looked at with respect to soil. Mm-hmm. I'll just qualify what I've said with mentioning that my background is AI and robotics. I'm a computer scientist by training in terms of education. So everything I've learned about plant science and agronomy has been things I've picked up in my role in LIAT, where I've been now for coming on 5 years. If I got any of that wrong, it's because it's not my training.
As a journalist, I've written quite a bit about agriculture, and everything you said sounded spot on to me. So
yeah,
and obviously, one thing that's on my radar with these things is if you are talking about a specialized robotic system going into fields, they tend to weigh a lot less than a lot of the farm machinery. So that's also reducing the soil compaction.
Yes, but the ones that don't weigh very much aren't necessarily the most robust in terms of being able to tackle the variation in terrain. So there's a reason why the tractor has evolved over 100 plus years that it has, and the shape of a tractor is the way you've got the large wheels and small wheels, and the sort of canonical shape of a tractor is extremely successful in a wide range of terrains all around the world. And so one of the things that we look at as roboticists is, if it ain't broke, why fix it, right? So there are cases where a tractor is not the right vehicle, but in cases where the tractor is the right vehicle, why don't we just roboticize that, put in some autonomous driving, for example, where it's appropriate, or autonomous actuation for spraying or weeding or harvesting using that particular vehicle. So there's a balance. Yeah. And, one of the things that I've found as I've been going to agri-tech conferences over the last few years is that there are a surprising number of people who work in robotics companies who are trying to apply their robotic solutions to the agri domain who've never been to a farm and never talked to a farmer. And my strong advice is go out and talk to some of the end users. And this is always the advice when doing any kind of technology development, is talk to the end user as early as you can in your development or research cycle, because they're going to bring up things that you wouldn't have thought of. And if you don't, you're going to end up designing and developing something that's not fit for purpose.
Yeah, definitely. So your research focuses on multi-robot teams and human-machine teaming. So can you talk a bit about how you're applying these approaches to agri-food?
Sure. I guess there's probably two key things that I'm looking at. One is efficient use of teamwork. So what are things that robots are good at, and what are things that people are good at? And can we take a job like harvesting and break it down into components and say, these are the elements of that mission that people should do, and here's the elements of that mission that robots should do. And one of the projects that we've had running here is called CoFruit, which stands for Collaborative Fruit Retrieval Using Intelligent Transportation, recursive acronym there. And what we do with that is we have a robot platform that can be used in the field, and we've been testing this in the soft fruit domain, so strawberries and raspberries. You can have a robotic vehicle that drives autonomously and works side by side with people in the field. So the people are doing the harvesting. You're still taking advantage of the unique skills that people have to identify when fruit is ready to be harvested and actually manipulate their hands to pull out fruit. It's a very tricky task because you have to be careful to only touch the fruit that you're harvesting. And ideally, like with the strawberry, you never touch the fruit, you only touch the stem. And then the picker takes the strawberry by the stem and puts it in the same kind of container or punnet that you get in the grocery store. So ideally, what you're eating is never touched by human hands until you, the consumer, is eating it. And anytime a human touches a piece of produce, they can introduce foreign biological agents that may cause disease or may cause the fruit to bruise and reduce the shelf life. And so, ideally, it's not touched by people at all. The idea with the Co-Fruit project is that people do the harvesting and they put things in these containers, and then the robots retrieve the containers from the people in the field. If there are no robots in the field, the way that soft fruit is harvested in the UK is that the human pickers pull all the fruit off, and then they have to carry the fruit to a packing station. And so the human robot solution that we're looking at is we have the humans just do the picking and the robots do the transporting. And there's a lot of components to that, including safety. How do you ensure that the robot is going to operate safely in close proximity to the people? But in order to be cost effective for the farmer, and I mentioned earlier about how farming is a very low margin. So, farmers don't have lots of money to spend on buying lots of robots. So likely you're going to have a ratio of pickers to robots in the order of, 4-1, something like that. So 4 people serviced by 1 robot. You want to make sure that the pickers are not waiting for the robot. So you want to make sure that they always have empty containers to pick their fruit into. And you want to make sure that the robots are also not waiting for people, although robots waiting for people is less expensive unless you have, if you have robots spending so much time waiting that you can reduce the number of robots, then there's another cost element there. So we look at modeling the speed at which individual pickers pick their fruit and make sure that we're sending the robot to the picker at the right time. And this involves doing some behavior modeling of what people do, where you doing that using data that the farmers collect anyway, because people are paid on what's called a piece rate. They're paid by the volume that they pick. So their payroll, the farms already compute payroll using that data. And so we're collaborating with farms that let us look at that data in an anonymized way. So I don't know, which individuals, but I can predict for any given team in the field, I can predict given what yield is estimated for that field, we can predict when will individual pickers be ready to have a robot arrive and pick up their fruit. I like to call it sort of Uber for fruit picking. And you don't have to call the Uber because it's going to be there ready for you when you need it. So that's one of the ways that we're looking at efficiency in human and machine teaming in the soft fruit domain. The other thing that we're looking at, which is newer work in the agri domain, is what's called shared decision making. And I've done some work for a while in an area called computational argumentation, which is a logic-based formalism for reasoning, which has its origins in AI and philosophy. And the idea is that there are many types of algorithms. Particularly common are computer vision algorithms, deep learning algorithms that produce some decision. And people don't necessarily trust what that decision is, first of all. Second of all, a lot of decisions are made in the field bringing together multiple factors. And so you might get a computer vision algorithm telling you one particular thing, but you might get some other algorithms telling you different things. And it might be about, should I spray today or not? Should I harvest today or not? All different kinds of decisions. And so how do you blend that information from multiple sources that can interact with a human user to decide what's the right thing to do at any given time? Now, this type of decision making is usually not something that you would do in the field at the moment of should I harvest this strawberry or not, but more sort of planning kinds of decisions about what should we do for this day or for this half day. And so we're using that in a couple of projects where the decision making is done by the farm manager, and we're looking at how do we help them balance their resources and their costs to produce the most benefit for their farm.
That's really interesting. So you co-founded RoboCupJunior, which is an educational initiative that runs a variety of robotics events for children and young people. Now, I'm really passionate about encouraging young people and particularly girls and people from marginalized backgrounds to pursue a career in robotics. So I'd love to hear more about that and some of the other work that you've done in this area.
Sure. RoboCupJunior is something that I started in the year 2000 with a collaborator who is a school teacher based in Melbourne, Australia. RoboCup, the annual competition and academic symposium, was held in Australia in August of 2000. And leading up to that, I got involved in RoboCupJunior because I was at the time finishing my PhD, and I was working on the use of AI and machine learning for educational software for young children. And so I got kind of interested in the idea of robotics for children. And so through the years, I've done a fair amount of work looking at ways in which we can interest a wide range of people in technology, in AI, in robotics. I think the key reason that we need to have a diverse population involved in technology development in general is because there are a wide range of users, a wide range of uses, and we need all perspectives in order to understand what are the best applications and what are the best ways in which to deliver those applications. So I think it's really crucial that the workforce, the whole workforce across the whole pipeline is diverse. When I started RoboCupJunior 20-some years ago now, there were not too many robotic competition events available for children. So this would be, with RoboCupJunior, we started with the age range between 8 and 18. So there was general agreement that because it involves programming, that the youngest students should be able to read on their own. Because it's a competition, we wanted to make sure that the kids were actually doing the coding and development, not their parents or teachers. And so we did have that restriction on the lower age. And we found that the really crucial time period for students is actually a little bit later, when you're sort of 16, 17 and deciding where to study and what to study as an undergraduate. And so while there are many initiatives for younger kids, sort of after school things, in the 8 to 12, 13 age group, it's less critical in terms of career decisions at that stage. I think it's really important to open the eyes of children and parents to the opportunities when they're young. But we have to keep going with these initiatives and make sure that as students age, that they still have these opportunities and things that they find interesting, as they go from age 8 to 16, and as they go on into their undergraduate and pick what they're going to do. So some of the things that we did was, when I was in New York for many years before I moved to the UK, and we did some work on a program for high school, like end of high school students and early undergraduate years for students. So kind of 17, 18, 19 age groups, where we taught students through summer programs. We gave them the opportunity to learn about computer programming, AI, robotics, and a range of different application domains. So not just focused on, what the programming language is, but more focused on what do you do with that programming language. And that's where robotics became a really interesting domain for students in those age groups. Following that, I did some work with developing training materials for school teachers. The UK has a pretty comprehensive introduction to computer science and programming and technology throughout the whole curriculum across the different key stages, but many classroom teachers are not trained in what those topics are. And a lot of times, even if you're a math or physics teacher, you might have done some programming as an undergraduate. But a lot of times the teachers who have scope in their curriculum or in their timetable to do something extra like robotics would be an art teacher or a music teacher, right? Who just had no technical background at all. So I did some work, which we started in New York and then continued some in the UK, doing training workshops for teachers through continuing professional development. So CPD training to help non-technical people gain enough background so that they could then subsequently teach some of this introductory robotics and help students further their experience with technologies. Most recently, I've been involved in doctoral training, and we've just recently been awarded a new UKRI AI Center for Doctoral Training that's called SUSTAIN, which stands for Sustainable Understandable Agri-Food Systems Transformed by Artificial Intelligence. This is a collaborative CDT that is led by University of Lincoln, collaborating with the universities of Aberdeen and Strathclyde in Scotland and Queen's University Belfast in Northern Ireland. So we'll be recruiting students for that to start in October 2024. The recruitment for that will start in the end of this month. And the idea is how do we use AI and robotic systems to help make sure that the agri-food system across the pipeline is sustainable. And we look at a number of different things, and it's an interdisciplinary CDT. So we'll be looking for people who want to develop technologies, but also people who want to learn about technologies and use them in various ways.
Fantastic. I mean, I think it's so great that you've kind of been able to promote robotics for such a wide range of different age groups, all the way up from, young kids right the way through to getting a PhD.
Well, it's been, I think, a pretty rewarding direction to go. And, I started looking at agri-food about 10 years ago. I came to the UK on sabbatical, and came initially for 2 years and then never really left. During that sabbatical, the first year of that sabbatical, I learned about precision agriculture, which is the idea of making a decision about what you do in a field at the level of the individual plant instead of the level of the whole field. Traditional decisions about, irrigation, spraying, harvesting are all done at the level of the whole field. Yeah. And you apply a pesticide to the whole field. But actually, we only need to look at individual plants. And the kind of robotic and AI technologies available today, because you can put so much computation on a small footprint device, means you can put things out in the field. How can you make those decisions at the level of the plant with that technology? And that's the idea of precision agriculture. So I got interested in that as part of my sabbatical. And prior to that, I'd been looking at search and rescue as a sort of application domain for robotics. And while that's a crucial area, one of the things that's frustrating as a researcher is that you don't get many opportunities to actually test that out in real world situations. I was lucky enough to be able to do a bit of testing as part of training exercises for first response teams, but never was able to actually go out and apply it in a real world setting. So I was interested in what's a domain where we can go out and help on a day-to-day basis. And so really got drawn into precision agriculture. And the more time I've spent looking at robotics in the agri domain, the more I feel it's really the killer app for robotics, because there are just so many factors that come into play, from the physical all the way to the software control and human robot side of things. So it's challenging. There's so much work to be done. So, I encourage people to think about studying and developing solutions in this area.
Yeah, absolutely. I mean, it's such a huge part of our, societies to be able to make food and provide sustenance for people. So yeah, it's clearly a very worthwhile area to be spending your time. Elizabeth, it's been lovely chatting to you today. I've been speaking to Elizabeth Sklar, a professor in Agri-Robotics at the University of Lincoln. Thank you.
Thank you, Claire.
Thanks for listening. If you enjoy Robot Talk, I'd really appreciate it if you could share the podcast and leave a review to let us know what you think. Don't forget to enter our competition for a chance to win your very own Robot Talk t-shirt. For more information about the competition and how to enter, check out robottalk.org. And make sure you check out our social media channels to see a photo of the Co-Fruit collaborative robot that Elizabeth and I talked about. We're at Robot Talk Pod on all the socials. Next week, I'm chatting to Josh Caputo from Humotech, all about robotic prostheses, exoskeletons, and prototyping. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.